So what we're going to be looking at today is, so we're starting unit 3 here. And so we are going to be looking at statistics. There we go. So we're looking at statistics here. So with statistics, the first two things, you've probably heard of these words. You might not fully remember what each of them mean. That's okay. But mean, median, and mode. This is the backbone of pretty much every like extra statistics that we can find here. But so this is primarily what we're focused on. I'm just going to zoom in here. So we're going to be looking at organizing data, right? That's what statistics is you're using data and you're figuring out what the data is telling you. What trends do you see? How can you use that information in a useful way as well? It's not just being able to categorize the data, it's being able to understand, oh, so this data is saying, you know, you're able to come to some type of a conclusion, an actionable conclusion with that data. So we often need to organize our data in ascending, which means going up, or descending, which is going down order, from smallest to biggest or biggest to smallest, right? That's a very common thing we're going to have to do here. One way that we can do this is with something that's called a stem and a leaf plot. So this is a common thing that we're going to end up using here. So basically, in a stem and a leaf, we organize the numbers by tens and arrange them in a table. What does that mean? Well, if I'm looking at this data down here, if I want to organize all of these numbers here, what do I see? I see I have, there's no like, there's no 0 to 9s, but I see I have, I have some ones, I have some 10s, I have some, oh no, there's a 0 to 9. I have 10s, I have 20s, I have 30s, 40s, 50s. No 50s, I can see. No 60s, no 70s, no 80s, and there's also 105. So I'm actually going to organize this through a stem and a leaf. I'm going to go down here to my next to my next page. So when it talks about a stem and a leaf, you're thinking about an actual leaf. So if you're looking at this leaf here, the stem is this middle part, right? It's the part that's going out and everything else is connected to it. So what we're going to do is we're going to put the tens column is our middle part, and then everything else is going to branch out. And if you're like, what the heck is he talking about? It's going to make sense right away. So we're going to, the first thing we have to do here is we're going to have to build our column. So we're going to just draw a nice straight line going straight down. And then I'm going to do another one. So we already established I had the zeros, I had the 10s, 20s, 30s, 40s, and 100. That's 5 different, that's 1, 2, 3, 4, 5. There's 6 different categories there. So what I'm going to do is first off, I'm going to split this up into 6 different parts. Three, 4, 5, and 6. So what this is basically saying is that when it talks about, hey, we're going to organize it by the tens and then arrange them in a table. Basically what this means is everything that starts with a 0 is going to end up in here. Everything that starts with a 10, so an 11, a 12, a 17 will end up in here. Everything that starts with a 20 will end up in here. Specifically, sorry, a 2 and a 1. So not a 10, but a 1. There's 3s, there's the 40s, there's no 50s, there's no 60s, there's no 70s, but there is hundreds. So just to give you an idea here, I know that I had a number here of 16, right? Well, I know, don't write this down yet. Everything you see right now is fine, but the stuff I'm going to add in blue, don't add yet. But if I'd say, hey, I want us to add 16, you would put that in there, for example. This is saying that, hey, you have a 1 and you have a 6. This means 16 as an example there. So that's what the concept of it is, but we also need to put these in smallest to biggest value. So, what that basically means is I'm going to start looking for ones. I don't see any ones here. I don't see any twos here, but I see a 3. So I'm going to put that there. And then that's it. That's all I have for the 3s there. Now, and you notice that I'm crossing it off here. You're actually going to be making those marks. I want you guys to actually cross it out once you're done with it. Because one of the biggest mistakes you'll make is, crap, I put something in twice. The next one is I'm looking at my 10s, right? This could be an 11, anywhere from, 10 to 19. So I'm going to start with 10. Do I see any 10s in here? No, I don't see any 11s. I don't see any 12. I see a 12. I don't see any 13s. I don't see any 14s. I don't see any 15s, but I do see a 16 at the very start. So next I'm going to put a little comma here and now 6. So this is saying that, hey, I have a 12 and I have a 16. And I'm going to keep doing that. I'm going to find there's no 17s, but there is an 18. There's no other 18s, and there is a 19. So it's just a way to organize these numbers pretty quickly. So same thing. I'm going to do the same for the 2s. There's no 20. There's no 20. Sorry, there is a 20. There's a 0. But there's no 21. There's no 22. But there is a 23. And there is a 24. And there is a 25. There is a 26. There's no 27s. And there is a 28. So I'm putting them from smallest to biggest. It's ascendant order. 4. And I'm just going to give you just a minute here to try out the 3s, 4s, and the 10s here. So I'll give you a minute and a half to finish that up. I'll quickly power through what's supposed to go in there right after. Give it another minute. just powering through what some of the other ones of these would be. For the threes, we'll have a 2, 3, 4, 5, and 6. They're bigger. The fours, we should have a 0, which means 40, a 3. There's 2 5s. So if you want to know what to do with that, there's 2 45s in this list. We have one there and one there. You put it twice.
Oh.
Yeah. And again, if you weren't sure with that, that's fine. Like, you learn it better this way. That's why I do that, even if it's annoying. And then there is 105. So I still just put that 5 in there. And so you've done it, you've done it right if you've paid really close attention here and you've slowly ticked them off. This is why it's very important. Put a little line through with a pencil or something, or do something to make sure that tells you that I've used it before. Because now I see that every single one of my numbers is cleared out. And so we've already done the second part. You can just write the numbers in. So maybe I could do like, 2, 8, 9, and 6. And then you could do it if you want. I like just going through it and put it in order right away, personally, but that's a personal preference. But your end result needs to look like this. It is in ascending order. It goes from smallest to biggest. That's both going down and that's moving to the right. Goes from 12 to 16 to 18 to 19. And it also goes from the zeros, the 10s, the 20s, 30s, 40s, and 100s. I did not need to put a gap to the 50s, 60s, 70s, and 80s. That's fine.
So ascending is smallest to largest.
Yes. Yeah. Ascending is smallest to biggest. Yeah. And then descending is going down. Yeah, largest to smallest. Think about like when you ascend a mountain, you're going up, right? When you descend a mountain, you're going down. So we're gonna skip this one. I think you guys can do number 1 here. What I want you to try out now is we're gonna try out question number 2 here. And you don't have a lot of space for this. I apologize. Part of the reason we're skipping number 1 is you might want to use the space up here. But let's think about it. Before you get started here, I just want to be like, okay, go, we're good to go. How are we going to do this? We have the heights of basketball players and we want to go from shortest to tallest, right? That is ascending order. And we want to use that stem and leaf plot. How am I going to get about this? What's specifically, what's going to be in my stem? Does anyone have any guesses what I'm going to end up putting in my stems here?
5, 6, and 7.
So you're thinking okay, so this is saying like 7 feet, 6 feet, and 5 feet. So you're thinking that. And so if I'm doing I'm doing this one here, the one I'm boxing specifically, you see there's a 4.5 here. So would I do a 6.4 in here? Or would I just put 0.45 in here?
You put 0.45 there.
You're right, I would do it. So yeah, you're gonna organize this stem as 5, 6, and 7. So just 3 nice easy ones. Put that in. So 5, 6, and then 7. So that's how you're going to start it out. I'm going to let you guys try this out here. I will start doing it in a couple minutes. You probably won't be done by then, and that's fine. But just in case you're not sure what to do, I will start this in a minute or two. So again, this is what it should look like at the end here, once you've added everything here. Where we're really going to go for now is we're actually going to go to, it's called and I hate that they call it this, I'm going to be honest with you, a measure of central tendency. Again, a lot of math is, it's a translation book. It's an average. It's mean, it's median, it's mode. That's what when it says a method of central tendency, it means the average, the mean, median, or mode. If you don't know what those are, that's what we're kind of focused on today. So A measure of central tendency is a number around which a set of data clusters. Again, it's a pool of data. It's a way of organizing it. In mathematics, there are several different measures. The most common one is the arithmetic mean. Again, if we're converting this to English, and you guys they're gonna ask you what the mean is, but when we're talking, as a human to a human, we say the average, right? I don't ask you, what's the arithmetic mean average temperature in July? I ask you, what's the average temperature in July, right? But that means average. Arithmetic mean means average. We also have a special symbol that we do. Remember, mathematicians, super lazy. Instead of having to write the average, basketball player's height adds up a lot, right? We use this symbol here. It's an X with a line over top of it. So instead of writing down the arithmetic mean is, we put, hey, the arithmetic mean, this X at the line is, maybe the basketball, I don't know what it is up there. It's 6.4 feet or 6 feet, 4 inches or whatever, right? It's a way to save space. It's a way to save time. It's a symbol to note that. So that is something you are going to have to memorize. That is not something that's going to be given to you on your formula sheet. So how do we find what the mean is? How do we find what the average is? If I say, okay, we're all going to take a test right now. Someone gets a 50, someone gets a 60, someone gets a 65. Someone gets a 90. So I'm just picking random numbers right here. Someone gets 100. How could I find what the average test score was?
Is that the total amount in the class?
Oh, sorry.
Is that the total amount in the class? Like 50, 60, 65. So there's only 5 students that took it?
I'm just picking random numbers, but in this example, we're saying 5, yeah.
Okay. So you would probably add all those up and divide it by 5. Yeah.
If I want to know what the average test score was in this specific case, I would add everyone's number up. I would divide it by 5, and I'd be like, boom, average class test score was, 75. That's exactly how you do it. So mean is literally, we are just going to add all the values up, and we're going to divide that number by the number of values in the set. Right? Add all the numbers up, divide it by how many data points there are. How many numbers were there? If 5 people took a test, that's 5 data sets. That's 5 numbers of values. So let's work through, pretty basic example here. I have this question right here. So how could I figure out what this is? Well, all I'm going to do is, first off, I'm not going to ask you guys to write this down. I'm just doing this to show it. If you know what this already is you do not have to write this down. But what I'm going to do on my calculator or in my head or on something is I'm going to add, this is what's happening. I'm literally adding all this stuff up. +6, +1. You're adding all the numbers up and you're dividing it by how many numbers there are. 1, 2, 3, 4, 5. The 0 counts. 6, 7, 8, 9, 10. So if I add all this up, I'm going to get, I'll just put it over here. Yeah, so the mean, and instead of writing mean, I use my little symbol here, is, you're right, it's 33/10. Which in reality is 3.3. That's what it is. This stuff up here, I don't need to see that fraction. No one needs to see that fraction. If that helps you, great. I will not dock you marks if you don't do that. If you just want to go straight to your calculator or just punch that in your head or do whatever you need to do, fine by me. But I do need to see you're using the symbol. I need to see this calculation. I need to at least see this part, and I need to see a final simplified answer. So those are the 3 parts: is you have the symbol showing its mean, you've shown some work of it, and then you've given me the answer. So 3 parts. So I'm gonna give you what do we got? We got 1, 2, 3, 2, 2. Yeah, gonna give you guys we'll say about 6 minutes. Try out question 3, 4, and 5. I might give you a little bit more, maybe 5 minutes. Try question 3, 4, 5 here on the next page. Give you a couple minutes, about 5 minutes for that. Ask for help if you're not sure. This is the time to ask for this help. The point of this is to cement these skills. I'm just putting some of those answers in here. And so again, these negatives here, you still count them. 11 plus 7 minus 2 plus 3, subtract 4 plus 5, subtract 7 should give you 14. How about 1, 2, 3, 4, 5, 6, 7? Should give you 2, right? Yeah. Again, just going through some of these answers here. 78 plus 95 plus 69 plus 101. And add 81 gives me 424. You divide that by the 5 games. And I can see that their average score is 84.8. And then same thing for this one here. It's negative 32.4. Technically, this is add in negative 33.4. Which is technically 32.4 minus 33.4 is technically what that is, but again, just kind of showing how that goes. So I'm just going to quickly power through this. 24.4. Again, your calculator can do all this hard work for you. Minus 0.8 minus, sorry, plus 3.3 now, because it's a positive temperature, plus 0.8 minus 9.2 minus 19.4 minus 26.4 minus 30.1 negative 216.2. Did everyone get that one?
Yeah.
Okay. So negative 216.2. So again, what I would need to see here is symbol, yes, is equal to the average, the total, the sum of it divided by the 12. Thank you. What does that give me? Like
18, negative 18.02.
negative 18.02 would be the average temperature. So that's like Antarctica. Oh no, it's Nunavut. Okay, yeah, northern Nunavut. That sounds right. Degrees Celsius. So again, I've shown that hey, the mean, I'm using the symbol, is equal to the sum of it divided by the data points. That's mark number 2 is the answer. Mark number 3. Okay. So let's try this one out here. So next one is what we have is we want, so now we're going to apply this. Okay. So I think we're okay with finding the average, right? Like this is something that everyone here's probably experienced at some point, done at some point. So how do we apply this? Let's find out. So it's not just about finding, it's about applying it. So a football team has offensive drives of 45, 43, 24, 21 yards, and 44 yards. The coach wants the team to achieve a mean, an average, of 35 yards per drive for the game. What's the length of the next offensive drive have to be if they want to meet this goal? So what this is saying is, like, right now, if I was to take this average, 45 plus, plus 43, plus 24, plus 21, and what's the other one? 44. So they've had 5 drives so far. And it's 35.4. I want to know, well, how far does my next drive have to be? Obviously, if it's 35, I've met my goal of 35 per game. But what if it's 34? What if it's 33? What if it's 32? Instead of having to redo that calculation, we can problem solve for it. So let's think about this way. If I'm saying that, hey, if I'm adding on one more drive, if I'm adding on a 6th drive here, and I'm saying that, hey, there's 35 per yards per drive, how many total yards is that? So what I'm going to do is I'm going to find the estimated number of drives. This is the fancy way of saying is I had 5 already, and he wants the next drive, which is the 6th one, to be what's counted. So I have 5 already, but I will have 6. I'm going to have 6 drives. So I'm trying to think, like, how many points do I need? Because this is important, and you'll see why in a second. The next thing is I know, well, what's my goal? My goal, don't write anything for number 2 yet. Don't write anything for number 2 yet. But my goal is I want to have 35 yards per drive, right? That's this guy's goal. He says it right there. He wants 35 yards per drive for the game. So if he wants 35 per drive, why can't he multiply it by the estimated drives? So multiply the estimated drives. Maybe spell it right. Multiply the estimated drives by 35 yards, right? Because he's saying, hey, I want to have at least 6 drives. So we're going to multiply the 6 drives by 35 yards. So literally 35 yards times, 6 times 35, right? If I do that, I know I need to get to at least, what is that, 210 yards. Between 6 drives, he needs to get to at least 210 yards. So I figured out the total he needs. This is the sum. So I have found the total sum of what he needs to have. So how could I problem solve this now?
You would add up all those yards together, and then you would do 210 minus those yards.
Yeah, I can take these 5 yards. I'm just going to quickly get back to that number because I know we did this. So I know it's 177. So why can't I just take the projected sum? Sorry, just the projected sum, subtract minus the current sum, sum, aka I want 210 yards. I have 177 yards. If I do the math there, that's going to give me 33 yards. So what does he need? He needs 33 yards. His next one needs to be at least 33 yards. So the 6th drive needs to be 33 yards. And if you're ever unsure, you can always check it. I can always just now add that 33 up there, divide it by 6. If it equals 35, I've met my goal. Because we already established he's a little bit over 35.4 beforehand. He was at 35. So he was at 35.4. He was a little bit over. So this seems to make sense, right? This is logical. Hey, he can get close, a little bit under, and he'll still meet his goal. So this is obviously a little bit harder. We have to think it through the problem. Again, the math itself is not hard. It's multiplying, it's subtracting, it's adding. But setting yourself up for success is where the difficult part is. So I'm going to let you guys try out these next couple of questions here up until question 8. So give you a couple of minutes here. Try question 6, 7, and 8. Ask for help with it. I won't be going through all of them. I'll probably pick 1 or 2 to go through afterwards. There we go. So what's going to happen the rest of the day is, so if you finish these questions here, again, if you have any questions, let me know. We are going to work on median and mode tomorrow, so we will finish up this topic tomorrow. Instead, what you could do is you'll have some time to practice some of this stuff here. Again, different problems. The more practice, the better. It's not just about finding it, it's about applying it. That's the hard part here. So in your textbook, you can go to page 118 and you can start working on some of the questions there. From questions 1 all the way down to question I think it was question 7, I think, if I recall. We don't know the mode, we don't know the median yet. We'll deal with that. Just do the mean stuff for now. But yeah, I'll give you guys some time for that. Again, if you have any questions with this, let me know. It's going to be really important to make sure we got this stuff down. Textbook, and that was page 80, 118. So the text, page 118.
What would you do number 7? I have such a tough time with these. Under thing. Just have a tough time with these.
Oh yes, so they got 4 grades. And so she has another test here where she wants to get an overall average of 67, or sorry, 86. So we want to figure out what score she needs to get here. So if she wants to get an 86 average, right? So just like before, we add up, test 1, test 2, test 3, test 4, test 5. Don't worry about the X's there. It's not an algebra problem. I didn't want to do 1, 2, 3, 4, 5. So we know, we know that if we do this, these 5 numbers added up, divide by 5. We know that at the end of it, we want to get at least an 86%.
Yeah.
So the same way is true. If that's the case, then these 5 numbers up here, they all need to equal, they need to equal whatever 5 86s are. Right? So I figure out that score first. So it's
Okay, so it's just like you would need 86 times. Oh, okay.
Yeah.
I didn't, yeah, that's why I keep okay, I get that.
Yeah, no worries. Yeah. So okay, so you think you can do it from that point on?
I'll see.
Or try it at least, yeah.